Welcome to College Algebra course. In this lecture, we're going to discuss about linear equation and also rational equations. This is Unit 7, lecture part 1, again, College Algebra course. Our main objective is to use the vocabulary related to solving equations and also identify types of equations. And also we're going to learn how to solve linear equations, also solving rational equations, which we did in the last lectures. Solve formulas for specific variables. So a variable x normally represents a number or a quantity. And the reason why x is called a variable because it can represent any value or any quantity of items. So in algebra or in mathematics in general, a variable represents any value or quantity can be assigned to it. So a statement indicating that two quantities are equal is called an equation. So always when we have an equation, previously we learned the rational expression. In rational expression, we saw example 2x squared plus 5x divided by 2x. It's not equal. There's no equal. So an algebra expression does not have an equal sign. Equation always have an equal sign, and we will see the difference. Again, our last lectures before this, we talk about rational expressions. This time we're going to talk about rational equations. Normally, in rational expression, we try to reduce the term to its lowest form. That's solving the problem, either by addition, subtraction, multiplication, or division. We are reducing the rational expression to its lowest form. For example, if 2x squared plus 3x is given to me, I can reduce this expression by finding the GCF by factorizing it. But in an equation, we're always going to solve for a variable. So example, an equation will be given 2x plus 3 equal to 7. My goal is to solve for the value of x. So that's equation. So again, we should know the difference between the two. The definition said a statement indicating that two quantities are equal is called equation. So example can be 2x plus 5 equal to 10. It's an equation. 2x plus 5 is an expression. So we use the vocabulary related to solving equations and also identify types of equations. Here we have a definition saying that any number that satisfies an equation is called a solution or root of the equation. And again, we're going to solve an example and explain what we mean by that. So a set of all solutions of an equation is called a solution set. So to solve an equation means to find a solution set. Example, I can find the value of x variable. Most of the time we find the result of the variable. So two equations with the same solution set are called equivalent equations. If we have two separate equations, but their solution set are the same, then the equations are the same. So we call it equivalent equations. So type of equations, we can have an identity. The definition of identity equation is every acceptable real number replacement for variable is a solution. So this is an example. S squared minus 9 equal to s plus 3 times s minus 3. It's difference of two squares, so the two is the same. So every real number x is a solution. Now we also have what we call the contradiction. Here we say no real number is a solution. No real number is a solution. So for example, we have s equal to s plus 1. There's no solution for a value of x. Because what will happen, if I take the x to the left side, I'll get s minus x. So that will give me 0 equal to 1. So here we say equation has no solution. Equation always, that's what we use the term equation. Equation always have a solution when we can find the value or the answer for the variable. The variable can be any letter, X, Y, Z, any letter. So in this case, if I have X equal to X plus 1, I cannot find the value of X because X, when positive cross the equal sign, become negative. So if I take the X to the left side, it will be X minus X, which will give me 0. So it's 0 equal to 1. We can't find the value of again, the variable. Here we can, because we can see that X squared minus 9 equal to the same value on the right side. So any real number is a solution. X can be 1, can be 2, can be any real number. Now the next one, we have a conditional equation. Here we say the solution set contains some, but not all real numbers. So example, here we have 3x minus 2 equal to 10. Here we say the equation has one solution, and the answer is 4. Not negative, not positive 4 and negative 4. So we say solution set contains some, but not all real numbers. Identity, every real number X is a solution because the left side of the equation is equal to the right side of the equation. The left side of the equation, again, is equal to the right side of the equation. So any real number X is a solution. Here, the left side of the equation is not equal to the right side, but we can still find the value of X. So X can be one single value, not every real value. So here we say there are 3 types of equations: the identities, contradictions, and conditional equation. These are defined and also illustrated in the following table, which we just went through. So properties of equality, the addition and subtraction properties. For example, if I have a variable A, B, and C, and we say A, B, and C are real numbers, and A equal to B, then what will happen? A plus C is equal to B plus C, because we are adding the same value to both A and B, so they are the same. Or we are subtracting the same value from A and B. Since A is equal to B, if I subtract the same value from A and same value from B, the answer is the same. Or if I add the same value to A and I add the same value to B, the answer is the same. So that is the, again, properties of equality. We have a variable A, B, and C. If A equal to B, then A plus C is equal to B plus C. Or A minus C is equal to B minus C. Then also we have the multiplication and division properties. Now the same thing, we have A, B, and C. They are real numbers, and A equal to B. The same concept. If I multiply C to A and I multiply the same C to B, then AC is equal to BC. In other words, if I multiply any value to A and the same value to B, both of them will be the same. It's the same thing with division. A is equal to B. So if I divide A by C and I divide B by C, A by C and B by C are the same. So those are, again, the property of equalities. We also have what we call the substitution properties. So example, in an equation, a quantity may be substituted for its equal without changing the truth of the equation. So let's see an example what we mean in a problem. So the easiest equation to solve are the first degree or linear equation. A first degree or linear equation means the variable exponent is 1. We may come to quadratic equation where the highest exponent of the variable should be 2, then cubic 3, etc. So since these equations involve first degree polynomials, they are called first degree polynomials equation. Most of the time we also use the term linear equation. Well, when you have an expression, the highest variable exponent is 1. If you plot the graph, or you put in the possible x and y, possible x value, and find y in a graph, you will get a linear line. And we'll come to that topic later. So a linear equation in one variable, say x, is any equation that can be written in the form ax plus b equal to 0. So our goal is that a and b are constant value. We are looking for x, the variable. So we will see examples soon, and also we are going to apply all the rules that we went through at the equality for addition, subtraction, multiplication, division, and also substitution rule. We're going to apply everything here. So now let's see our first example. We have 3 in a parenthesis s plus 2. We know in parenthesis means multiplication. So here I can say 3 times s plus 2 equal to 5s plus 2. This is an equation because we have equal. The left side of the expressions is equal to the right side of the expression. So this is an equation. So our goal of an equation like this, we are looking for the value of the variable x. So first we can do our distributive law by multiplying 3 by s plus 2 to remove the parentheses. And that's what we did here, 3s and then 6, because 3 times 2 is 6, 3 times s is 3s. Now we can take the like term to the left and the constant values to the right. And this is what we get. So let's go through step by step. You see there's 2 options. Now if I take the like terms to the left and then the constant value to the right, I'll get 3s minus 5x, then 2 minus 6. At the end, I'm going to get 4 equal to 2x also, because 2s minus 5s will give me minus 2x. 2 minus 6 will give me what? Minus 4. Minus 2s minus 4. If I multiply the equation by minus 1, I'll get 4 equal to 2x. That's the fastest way to solve this problem. But here, we want to use the previous rules we talk about, the equality of addition, subtraction, multiplication, division, and also substitution. So what we do here, okay, I have 3x and also I have 5x. Always I'll try to remove the lowest x variable coefficient. So if I have 3x, then I can use minus 3s. So this is again subtraction equality. Now if I use minus 3s to the left side of the equation with the equal sign left side, I have to do the same thing to the right side. So I have minus 3x here, minus 3x here. The equation is still balanced. That is the equality. See, here I'm going to say right side of the equation because of the equal sign to my right, or left side of the equation means the equal sign to my left. So I use minus 3s here, minus 3s here. What we are doing is that we are trying to eliminate the 3x. So if I have 2 variables, the lowest coefficient variable is what I will remove. So here I will remove 3s and leave 5x. So at the end, we get 6 equal to what? 5s minus 3s will give me 2x plus 2. Now I'm here. I have 2 here to my right, and also I have 6 to my left. So I want to take one constant value out. So I'll use minus 2 to the right, minus 2 to the left also. So to balance the equation, so it's still equality. We are using the equality rule. So here we get 4 equal to 2x. Now I'm going to use another equality rule for division. I'm looking for x, but x is multiplied by 2. So I'm going to divide both sides by 2. And that's what we have here, quotient equality. So at the end, we saw that x equal to 2. So again, as we said, always an equation, we are finding the value of the variable. An expression, as we did in our previous lectures, we are trying to reduce the expression to its lowest term or form. So solving rational equations, let's try one example here. Rational equations are equations that contain, again, rational expressions. When we talk about rational expression, we mean it's a fraction. We know we cannot divide by 0, as we said earlier about rational expression. This is rational equations. So let's see an example. So this is a rational equation. Why? Because we have equal sign. So we say the left side is equal to 1. Our goal again is to find the value of x. Again, if there's no equal, this will be called rational expression. And our goal is that we have to reduce it to its lowest form. Here, equation means we look for the value of a known variable given. So solution, note that s cannot be -3, because if s is -3, the denominator will be 0. That will cause the denominator of the first fraction to be 0. And that's not good. So we keep going. To find other illustration, we factor the trinomial in the denominator of the second fraction. So you see that we are using the same techniques we did for solving rational expressions, because our goal is to find the value of x. But this expression here is very long. So our main goal here is to reduce this expression. That's our main goal. So here we can factorize x squared plus 2s minus 3. It's a trinomial. So we get x and x, the square will give me 2 factors of s and s. What two values? If I multiply, I'll get -3. If I combine, I'll get +2. And that will be +3 and -1. -1 times +3 will give me -3. -1, +3, combined together will give me +2. And that's what we got here. So we'll get s plus 3, s minus 1. Because s squared will give me 2 factors of s and x. Then -3, I look for two values. When I multiply, I'll get -3. And that will be +3 and -1. When I combine, I should get +2 in the middle. Okay, so if that's the case, we substitute, and this is what we get. So now we can see that we have what? S plus 2 over s plus 3. We didn't do nothing to it, but we factorize our trinomial to get s plus 3, s minus 1. So in this case, we can find the LCD. We can see LCD will be s plus 3, s minus 1. We want to combine these two terms together because there's a plus between. It's like if I'm doing the rational expression, that's what we're going to do, to combine, reduce it. So that's what we do here. So we have s plus 3, s minus 1, that's our LCD. So we multiply it to the left side, and we multiply the same thing to the right side. We balance the equation again. Now let's see if we can cancel some few things. Multiply both sides by that. That's what we did. We always multiply the LCD. After you find the LCD, you multiply it to the both sides. This is an equation. Before now, we substitute and combine. So from here, we were able to cancel some few things because we have s plus 3 down s plus 3. So we cancel. So we get s minus 1 times s plus 2. Here we cancel everything, so we get only 1. So later we're going to combine s minus 1 times s plus 2. The answer we get +1, and that's what we have here. And at the right side, we only have 1 times the LCD, so we get the same value. We remove the parentheses, back again to s squared plus 2s minus 3. The reason why, let's go back once. The reason why we find the LCD here, so that we factorize the trinomial here, so that we can be able to find the LCD. I don't want to use these two because it will be too much. It's like I have 8 and 2, and I say the LCD is 16. 8 is okay, the lowest, because here s plus 3 was inside here after we factorize. So our goal is to find the minimum value for the LCD, and we use it to multiply. So what we did in the next slide is that I multiply LCD by the first term here, and also I multiply the LCD by 1 over s plus 3 and s minus 1. So basically they will cancel each other. That's why we have 1 here. The s plus 3 will cancel s plus 3. So we get s minus 1 times s plus 2 equal to s plus 3 times s minus 1 times 1 will give us the same s plus 3 times s minus 1. And that's what we have here. Later we multiply everything, remove the parentheses. So we remove the bracket by multiplying. That's why we get this. Then later on, we can combine the like terms. Luckily, look what is going on. We have only s squared here, s squared here. So we use minus s squared here. That will cancel the s squared out. So after we cancel the s squared out, we get s minus 2 plus 1. S minus 2 plus 1 will give me minus 1. S minus 1, because minus 2 plus 1 will give me minus 1. And here we still have our 2s minus 3. So here now, we should take the lowest x. So we have minus x again. And that will give me 2 equal to x. So our value will be 2 equal to s, or s equal to 2. Now, to make sure our answer is correct, we can substitute 2 and make sure the left side is equal to the right side. So when we substitute 2 to our original question, this is our original equation. Everything here should give us 1, otherwise we have problems. So we find out this 1. So again, 4 by 5 plus 1 by 5 will give me 1. So one more time in this expression, I will go back one more time from beginning of the equation. Now, this is our question. This is an equation, equal. So as we said earlier, anytime we have equation, our goal is to find the value of the variable. So in this case, we need x. I have two expressions here. The previous expression, if I have, for example, s plus 2 over s plus 3 equal to 1, I don't need to find the LCD because we don't need to combine the term. But here I have plus or minus here, then we find the LCD to combine the two terms. If there's a multiplication, I'll just multiply the numerators together, multiply the denominators together, and combine as one. But if it's plus or minus, we have to find the LCD. Now, because we have trinomial here and we have binomial here, I cannot say the LCD should be multiply s plus 3 by s squared plus 2. It will work, but what will happen is that the expression will be too big. So I want to factorize this to see if I can get s plus 3 in. And that's what we were able to find here. Okay, if that is the case, then the LCD should be s plus 3 times s minus 1. So I will multiply that LCD with the first term here, which is s plus 2 over s plus 3. And now multiply it with the second term. Then later we solve it, reduce the expression. And that's what we did here. Now, anything, we remember the equality law. Anything we do to the left of the equation, we have to do the same thing to the right. So if I multiply the LCD with the terms on the left, I have to multiply the LCD with the terms on the right, which is only 1. So from there, we multiply the whole equations, and we cancel. When we look down here, we can see that s plus 3, s minus 1 multiplied by this section, it will give it the same s plus 3, s minus 1 divided by s plus 3, s minus. So they cancel each other, we get 1. Here we cancel s plus 3, s plus 3. So we get s minus 1 times s plus 2. S minus 1 times s plus 2 will give us s squared plus s minus 2. Then plus the 1 when we divide it to the 1. Then here we multiply the two terms together, we get this. So finally, our answer is remove the x. When I remove the x, I'll get only one x here. And then I have negative 3, negative 1. Let me take the positive 1 out. I will get negative 2. Now, the 2 cross the equal sign, we get s equal to 2. That's why then we get 2 equal to s, or normally we say s equal to 2. Now, if we are not sure of the answer, we say we substitute the final answer to our original equation to see if the left value is equal to the right. Since right is 1, our left area of the equal sign should be 1 also. And that's what we got here. Now, solve formulas for the specific variables. Now, the rules of the equality, addition, subtraction, multiplication, division, we can use it to solve any linear equation. Or we also use the same simple equations with different formulas. So example here, we have a formula saying f equal to 9 by 5, c plus 32. This is normally the Fahrenheit and Celsius degree when we are converting. So here, if I'm looking for c, Then what I will do, I'll take the constant value out first. So I'll use minus 32 to the left, minus 32 to the right. And that means I'll get f minus 32 equal to 9 by 5c. 9 is multiplied, so I will divide here by 9, divide the left side by 9. 5 is dividing, so I will multiply c side by 5. And then, so you see, we're using the equality, the 4 basic addition, subtraction, multiplication, division to balance. So let's see how they solve it. So first we say we are solving for c. So we use the same method as for solving any linear equation. Again, the 4 equality. So this is my question. What we decided to do is use minus 32 to cancel positive 32. So later I'll get f minus 32, 95c. Then next I have 95c, so I'll multiply by 59 to the right side so that I'll cancel 9 and 5 and get my c. But since I did it to the right side, I have to do the same thing to the left side. So finally, you see that our c equal to what? 5 by 9 f minus 32. We can change the form. Basically, what we are doing here is to combine the 9 should multiply everything. So I open the parentheses, 5 times f, 5f, 5 times 32, 160. So it will be 5f minus 160 over 9. So this will be the conclusion of our lectures again on linear equation and also rational equations, which sometimes we refer to as a simple equations. Thank you. Wish everybody the best.